you doing? Okay. So I have y plus 3x equals 180 from these two linear pairs, and I have 5x minus y equals 180 from these two linear pairs. Do you guys see what is about to happen here? Let me just rewrite it. What happens now when I start comparing those systems of equations, Frank?
I don't remember what it's called. It's not substitution.
Yeah, it's not substitution. You're correct. Even though you could use substitution here. Elimination. Because take a look. What's going to cancel out right away? The y's are gone. So you're just left with how many x's? 8x equals 360. Everyone see how that worked? I just put the two equations on top of each other like you had last year. These are gone. And I'm left with 8x equals 360. Divide both sides by 8. We should end up getting 45. Yes.
I did the 2y plus 2x and just got y equals x and then did substitution from there.
Yes. Yep. The substitution. Yep. That's fine. You could have also, let's say I could have moved the 3x over and got y equals negative 3x plus 180 and then substituted that into the other equation. Yes, substitution is definitely a viable method here. Now that I got x, how do I find y? Pick one of the equations we just came up with. So let me take y plus 3x equals 180. Take 45. Substitute it in for x. Now I have y plus 3 times 45 equals 180. Solve for y. Y plus 135 equals 180. And y also comes out to be 45. And again, I'm just showing you one way. This is one of the many. Rose just said a totally different way, which was absolutely correct. All right, this is one of many ways. But you did have to set up two equations at a time, though. Questions right now? Anything? An unusual question I get is something like this could be on the test? Did we just do it? Okay, there's your answer. All right. I'm not going to go crazy with the system of equations because I didn't think this one was too bad because the y's canceled out right away. I don't think I'd give you something where I'd end up elimination. Remember, you might multiply one by a number or multiply both by two different numbers. I wouldn't go that far. All right, but definitely something you could set up two different equations and get after it. Good? All right, another proof. One of the proofs I wanted to go over. Number 4. I want to make sure we're all understanding how to properly use substitution. Because what I find is a lot of you guys do all this in your head and you just write down one substitution, but there's more than one substitution here. Okay, so make sure you got down more than one substitution. All right, I have to know exactly what's going on in your head written down on the paper. So the first thing, I know 1 and 2 are congruent and 2 and 3 are congruent. Right away, before I even look at the diagram, because I know you guys see a bunch of vertical angles up here. If 1 and 2 are congruent, 2 and 3 are congruent. Give me something to conclude just from those. Frank. Angle 1 is congruent to angle 3. That is one substitution. Because I know some of you are going in your head, oh, 1's congruent to 3, 3's congruent to 6, 1's congruent to 4. That means 4 is congruent to 6. 4 is congruent to 6, substitution. But you just did about 3 substitutions in your head that I need to see on paper. All right? Does everybody see the one substitution I just did right here? Okay, so that takes care of that part. Now let's go to the diagram. Give me a pair of vertical angles in that diagram that are congruent. That hopefully involve 1 and 3, 4 and 6. Maddie? 3 and 6. So angle 3 congruent to angle 6. Vertical angles are congruent. Okay? I'm going to avoid writing down more vertical angles because I think it's going to get confusing. Look at these two right now. You guys came up that 1 was congruent to 3, 3 was congruent to 6. What do you got for me? That must mean what two angles are congruent then? If 1 and 3 are congruent, 3 and 6 are congruent, so 1 and 6 are congruent. And what did you just do again? You did substitution. Do you see how many times you're substituting here? You're just not doing it once to get here. I need to see all those substitutions. Okay, I got 1 congruent to 6, but I need to get 4 congruent to 6. We're almost there. Almost. Any other pair of vertical angles up there that'll help me out? Any other pair that I have not? Maddie, go ahead. 1's congruent to 4. They're vertical. So 1's congruent to 4. Again, vertical angles are congruent. And now again, look at steps 4 and 5. What can you tell me finally? 6 and 4 are congruent. Because you guys are at this beginner level right now, I highly recommend listing everything out separately. Could you have put 1 congruent to 4, 3 congruent to 6 in the same statement? Yeah, you could have. All right, I don't know how many of us are at that point where we can put it all in one statement and still show all these substitutions. Guys, you get my point with substitution. 2 at a time. Only 2 at a time. I get some of you in your head were like, oh, okay, 1's congruent to 3, those 2, so 1's congruent to 6, and then I got 6 congruent to 4. 1 substitution. No, you did. You did a bunch. You did 3 substitutions right there in your head. Do we see that? If that could come up on Friday. Right? It's just not 1 substitution. Right? 2 at a time. 2 at a time. Look at 2 at a time and substitute. All right, that's all I wanted to go over. Back to you guys before I ask for anything you wanted me to look at right now. It's either proofs or algebra before I ask you what you did. Because we are done with this unit. Today is just grinding out proofs with your group. All right, I'm not doing anything up here. Anything we want to go over before I ask you? Okay, let's start with the algebra then. Let's start with the algebra ones. So let's start with, looks like number 6. Is that, or did I miss one? It starts with 6, correct? Okay. Again, just give me the values, not looking for any justifications, because I'm sure you guys are fine. I'm not looking for anything in particular. Just why you set up the equation like you did for justifications. Here we go. 22, ready to go? Let's start with JLN. MLK. 90, KLO. 42, and JLO. $1.38. Questions before we move on to the next one? Nice job. Okay, moving on. Ooh, hey, 7. How we doing? Here we go. Number 12. Let's start out with HKI. 56. HKG. 124 and GKJ. 146. Anybody want to go over anything there? Because those are all correct. All right, let's move. 8 then. What are we looking for 8? 24. Here we go. ABD. 24, not here.
70.
70. How about DBE? 70. Way to redeem yourself. One job. Here we go. Let's go to 9 now. How about 7? Number 7. I'm sorry. We're on number 8. And number 7 in the class is... No, we're on 9, aren't we? All right. Calm down, everyone. Okay, here we go. FKJ. FKG. 50? Aren't those two congruent? That's what I thought. 40. GKH. How'd you get 90? What? Yeah, we're on 9. You told me 40, 40 right there. And now you're looking for this angle, which completes the straight line. 100. We all right? Okay. Well, you said 90, so. No excuses. Here we go. JKI. 140. 1 out of 4 ain't bad. Questions? And then number 10, because we already went over 11. Number 10, what are we looking at here? 10. 7 again. Redeem yourself. Let's go. Redeem. Redemption. DEB. Did you miss that one because it was kind of off to the side?
Yeah.
Okay, well, I'll get back to that. AEC.
140.
Okay, you ready? Here's AEC. Here's DEB. Now get back to DEB for me. 120 because they're what type of angles? Good, smarter than you look. Here we go. AED. Ready? What did you just tell me for this AEC?
120.
So the angle next to it, which I'm asking now, shouldn't be 50 because that would add to 170. Yeah, I know that. But what I'm saying, ready, Evan? What I'm saying is it can't be a 120 and 50 because that adds to 170. 60, and how about CEB? 60. All right. Anybody want to go over any of those? That was painful. Okay, back to the proofs now. Let's just make sure we had everything we needed. Here you go. Number 1, I'll go through these quickly. Number 1, one of two ways. You could have said the straight angles were congruent, subtraction, substitution. Or you could have said angles 1 and 3 are supplementary, angles 2 and 4 are supplementary, linear pairs are supplementary. And then said angle 3 and 4 are congruent because supplements of the congruent angles are congruent. So subtraction or supplements of congruent angles are congruent to get 3 and 4. Okay, 2 we did in class, or you did in your group. Here you go with number 3. Here's another example, what I was talking about with the substitution. You know 2 was congruent to 4, right? You also know 4 is congruent to what other angle because they're vertical? 3. So what can you do with that given and those vertical angles? What can you get out of those? Because here's the givens. Here's step 2. Step 3 would be what conclusion based on these two? 2 is congruent to 3, substitution. Then you could tell me the other pair of vertical angles down below, which are angle 2 congruent to angle 1. And then finally, you could get the proof statement, which is 3 congruent to 1. Do you see 2 substitutions here? 2 substitutions. Again, it's not 1. Get that out of your head, please. It's not just going to be 1. All right, there's 2 times I needed to substitute to get to that final product. Yes, Julia.
Well, I only substituted once because I did so I had the given, and then
Yep.
for the second step I said angle 4 is congruent to angle 3, angle 2 is congruent to angle 1.
Yep.
So there's vertical angles.
Okay, that's fine.
And then the third I substituted.
But you need to show me 3 congruent to 1. You just don't. Here's the issue with this. When you say 3 congruent to 1 by substitution, I am going to look for 2 pairs of equal quantities that I can get 3 congruent to 1 from. And if I look at your proof right now, I don't think I could find 2 of them that lead me right to 3 congruent to 1. See, I could find one that probably gives me 2 congruent to 3, and then I could get 3 congruent to 1. See what I'm saying? You still substituted twice to get here. Is everybody good? All right. When you use substitution, take a look up here again. I need to use 2 at a time. I need to use 2 at a time. That's when you can use substitution, 2 at a time. Okay? And then we're almost done, right? We just went over that one. Okay, 5. You needed to say 2 is congruent to 3 because they're vertical. Vertical angles are congruent. And then you could have said 1 congruent to 4 because complements of congruent angles are congruent. Yep, complements of congruent angles are congruent. And then we're back to the algebra. Anything you guys want to go over before I leave you on your own now? take a look quickly at this first proof before I let you go into your groups. Just so we're off on the right foot here. You just look at don't set up anything yet. Just look at the givens. Everyone see the word bisects? Okay, how many angles are getting bisected? Just one. So halves of equal quantities should not come up because you need how many angles to be bisected for halves of equal quantities? 2. Okay, so this is not halves of equal quantities, but you are going to use the fact that it does bisect and cut it into 2 congruent angles. Okay, after you do a proof, I would like to check it, please, in your group. Okay, I would like to check it before you move on to the next one. Okay, so a lot of work here, a lot of grinding out these proofs right now. You are doing your homework too, by the way. All right, your homework is to finish these proofs if you don't finish them. Okay, so the more you work, the less homework you're going to have at the end. Okay, so again, call me over if you think you and your group have it, or if you're just stuck. All right, I'll give you a couple tips.